Hello. In this session, we are going to explore one of the most crucial parts of central processing unit, that is CPU, something called as control unit, often called the brain behind the brain. Now, if you think of CPU as the heart of the computer, then control unit is the rhythm. It decides when and how each part of the CPU beats and functions. Let's start with the basics. What exactly is a control unit or uh, known as CU? The control unit directs and coordinates all the activities inside the CPU. It doesn't actually processes or calculate data. That's the job of ALU, that is arithmetic logic unit. Instead, control unit tells each component when to act and what to do. Think of it like an air traffic controller at an airport. Planes, let us say our instructions, are constantly taking off and landing. The control unit ensures that no two planes crash into each other and everything moves safely and smoothly. It manages the flow of instructions and data, making sure that every step, that is fetching, decoding, and executing, happens in the perfect order. In short, the control unit keeps everyone in the CPU doing the jobs correctly. So when you play a song on your computer, the control unit makes sure the instruction to fetch the song from storage, decode it for playback, and send it to the speakers all happens in proper sequence. Now, let's break down the three key functions of the control unit. Remember these three words: fetch, decode, and execute. Fetching instruction, that is, the control unit picks up the next instruction from memory. Decoding instructions, it reads and understands what needs to be done. And executing instructions, it tells ALU or memory to carry out the instruction. The control unit itself doesn't do the work. It simply tells who should do what and when, like a film director giving clues or cues to the actors. Think of a director shouting action. Actors, that is ALU memory, perform. The camera, that is IO system, captures. But the director, like CU, your control unit, ensures everything happens in the right order. So let us understand why control unit is important. Why do we need such a unit? Is the main question. The control unit ensures efficient operation and seamless integration among the CPU components. It is like a team leader. Without it, the team members might still exist, but they would have no coordination. It helps the CPU to handle complex tasks smoothly and quickly. For example, imagine you have a group project. If everyone starts working without coordination, you will have confusion and may lead to duplication. But if one person takes a charge, decides who researches, who writes, who presents, who codes, suddenly everything falls in place. And that's exactly what the control unit, that is CU, is doing inside the CPU. The control unit performs two main roles: managing data traffic and maintaining the order and timing. Like a traffic police officer, it ensures that the data moves correctly between memory, ALU, and IO units. No collisions, no delays. The control unit keeps tasks in sequence and ensures that they happen at right moment. And that's why timing is critical. Imagine if your computer tried to add numbers before fetching them, that would be the chaos. Think of a busy roundabout in say Pune. Without traffic lights, everyone would crash. The control unit acts like that signal light, controlling when to stop, when to go, when to wait. The control unit doesn't just send commands, it harmonizes operations. Just like the music conductor, it ensures that every musician, that is CPU component, plays in sync. If even one note is offbeat, the whole performance sounds wrong. Similarly, the control unit coordinates all interactions. So the CPU's performance remains fast, stable, and error-free. So when you play a video game, your CPU handles visuals, sounds, player input all at once. And that's what the control unit ensures all these actions happen in harmony. So the game doesn't freeze or never results to a glitch. Now let's look deeper into the key functions of the CU, that is control unit, starting from instruction fetching. The control unit begins by retrieving the next instruction from memory using a register called program counter. The program counter tells the control unit where the next instruction lives in memory. After fetching one, it automatically points to the next, keeping the CPU busy and smooth. Think of a librarian with a list of book numbers. Once he or she picks one book, then the librarian moves to the next number on the list automatically. And that's how the program counter keeps the CPU organized. After fetching, the control unit now decodes the instruction. This means that it tries to understand what operations needs to be done and what data is involved. An instruction usually has two parts: operation, what to do, like addition, data movement, and operands on what, like which registers or memory addresses. By decoding, the control unit figures out exactly what to tell the ALU and other parts to do. If the instruction is, say, add A and B, the control unit interprets it as fetch data from A, fetch data from B, and tell the ALU to add them and store the result. Once the control unit knows what to do, it manages how data moves inside the CPU. It makes sure the right data goes from memory to registers or ALU and back without mix-ups. Timing here is very crucial. If data arrives too early or too late, the CPU could make errors. Think of how delivery vans or delivery boys move around a city. The control unit is like a dispatcher, ensuring that every parcel or data reaches the right address, that is register or memory, at the right time. Now comes the exciting part: execution. The control unit sends control signals to the ALU to perform specific operations like addition, subtraction, comparison, and so on. It also maintains timing, ensuring that no overlap or missed steps. That synchronization keeps the CPU accurate and reliable. So when your calculator app adds two numbers, the control unit tells the ALU exactly when to start and when to stop, ensuring no calculation overlaps with the next. The control unit also manages the control bus, which carries control signals between CPU components and IO devices. These signals tells whether the data should move to or from memory or input or output devices. So basically, the control unit is the one deciding when the CPU should talk to memory or when it should listen. So when you click print, the control unit sends the signal or control signal to the printer port through the control bus, and it ensures that the data reaches the printer after the instruction is processed, but not definitely before. So finally, after completing an instruction, the control unit updates the program counter to point to the next one. And this automatically stepping ensures smooth and continuous operations. One instruction after the another without any pause or confusion. It's like a queue system at a grocery store. After serving one customer, the counter automatically moves to the next person in the line. And that's how the CPU stays organized, instructions after instructions. So to sum up, the control unit may not do the calculations, but it's the real master coordinator. It fetches, decodes, and executes instructions, manages timings and data flow, and keeps the CPU synchronized and efficient. So without this control unit, the CPU would be just pile of electronic parts, powerful but clueless. With it, everything comes alive, like an orchestra playing perfectly under a skilled conductor. And that's the power and beauty of the control unit. Silent but supreme.